Well, good morning, good afternoon, and good evening to my friends around the globe. Welcome to the latest NativeScript webinar. We have a lot of goodies to cover in a relatively short amount of time, so let's get rolling. Today we are covering the very latest from the NativeScript framework. This, of course, includes features that landed in the 4.0 and the 4.1 releases. We're also going to take a look at updates to our Angular and Vue.js integrations, and talk a lot about new and exciting web and mobile code sharing strategies for both frameworks. First things first, who is this dude in the lower right corner? My name is Rob Lauer and I manage the NativeScript Developer Relations team here at Progress. I'll be your MC today as we shift between all of our great speakers. So before I get started, I do have a quick set of logistical items for us to discuss. The first is, if you run into any technical difficulties seeing or hearing this webinar, rest assured we will have a full recording available on YouTube in the coming days. You'll get a post-webinar email with a link to the recording. You can also learn about the recording via Twitter, so follow us at NativeScript for all the latest news and mobile app gossip. Likewise, during the webinar today, you should use the Ask NativeScript hashtag on Twitter to ask us any questions you want. Want to know if it's Laurel or Yanni? Ask away.
Laurel. 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 Laurel.
Correct answer is Laurel, by the way. Now, to stay up to date on NativeScript, I highly recommend you take a moment to subscribe to NativeScript News. We send out some really great info in this email newsletter, usually once a month or so. And if you're looking for live help with NativeScript, look no further than Slack. We have over 7,000 folks ready to lend you a hand. Sign up at tinyurl.com/NativeScript Slack. You can also, of course, check out the community forum available at forum.nativescript.org. You'll find a lot of great resources there as well. Now, if you've been paying close attention lately, you may have seen a new tab appear on the NativeScript Marketplace. We recently released an extensive set of NativeScript code samples. So everything from basic geolocation examples, to a styled login form, to gorgeous list views and filterable newsreaders, there is really a lot to love in these code samples. Now, each code sample is also fully compatible with the NativeScript Playground. This means you just need a web browser and your phone to view the app. All the code is free and open source as well. Works equally well on both iOS and Android. And many of the samples also contain versions supporting Angular, Vue.js, and plain JavaScript. So check them out today at market.nativescript.org. Now, I know that we often get a lot of new NativeScript developers at these webinars, or even some people who are just curious. Well, hello to all of you. For your reference, NativeScript is a free and open source framework used to create truly native mobile apps for both iOS and Android from a single code base. Now, it's not Cordova or PhoneGap. It's more like React Native, but for Angular or Vue.js. So you do use your web skills like JavaScript, CSS, and an HTML-like markup language to create these apps. You also have the option of using two of the most popular JavaScript frameworks available today, Angular or Vue.js, or no framework at all. If you haven't already, take a look at the NativeScript Playground to get started on your native mobile development journey. All right, so what are we covering today? We'll of course be covering NativeScript v4. We've introduced a lot of new features and improvements over the last two releases. We're talking 50% improvement in startup times for Android in the 4.1 release, improved augmented reality support, a new flexible frame composition system, CSS gradient support, and a lot more. We will spend a good chunk of time on Angular today. There's been a lot of news surrounding Angular lately with the release of Angular 6 and certainly plenty of interest in Angular Schematics. We will also take a look at our other favorite framework, Vue.js, and Jen will tell us what's cooking there. Now, for both Angular and Vue, we're going to spend some time talking about code sharing. This is the concept of taking existing Angular or Vue.js web code and utilizing it in a native mobile app. In many cases, you can reuse up to 80% of your existing web code with NativeScript. Why is this important? Well, It's usually better to write less code, right? Which is what our code sharing strategies let you do. And speaking of code sharing, as we look to the future, we're looking beyond a vision of native mobile apps. We know that different scenarios require different mobile experiences. Sometimes you just need a mobile web presence like a progressive web app. Other times you require an engaging native mobile app that is performant and accesses native APIs. And many times you need both. So the ability to create multiple experiences from a single codebase is critical. Now Progress, the company supporting the open source NativeScript framework, is here to provide everything you need, whether it's a web and or native front end with NativeScript and Kendo UI, as well as a robust and compliant backend in Kinvey. NativeScript is a key component in Progress's mobile strategy going forward. All right, let me introduce our speakers today. Coming up, we have Jen Looper, a senior developer advocate here who is also co-founder of Vue Vixens, which I'm sure you'll be hearing a lot about. We also have TJ Van Tol, who is a principal developer advocate here at Progress. And we have Sebastian Vitalitz, a senior developer advocate who is our resident Angular expert. Speaking of Angular, I am super excited to also have Stephen Fluin here today. Stephen runs developer relations for the Angular team at Google. So take a moment, follow all these folks on Twitter. These are really the real experts. And as a quick reminder, get your questions in on Twitter with the Ask NativeScript hashtag. And just a note, if you stick around to the end, I will be providing a sneak peek at the 4.2 release, which of course is just around the corner. So all right, let's start off with Stephen.
Hi, my name is Stephen Fluin, and I'm really excited to be part of this webinar and to have a chance to talk a little bit about how Angular is trying to push the limits of what web developers can do through the introduction of a few useful tools. I'm going to walk through a few things. I'm going to walk through this idea of a new command that we've introduced as part of Angular called ng-add. Then I'm going to walk a little bit through something called ng-update. And then I'll talk a little bit about how both of these commands are built on top of an extensible platform that we call Schematics. So to start off, one of the things that we released as part of the 6.0 release of Angular is a great new CLI command called ng-add. To summarize, ng-add is a command that developers can execute that adds a capability to their project. So you can use this in a lot of different contexts. For example, on the Angular team, we have something like ng-add at Angular/PWA, ng-add at Angular/material, and ng-add at Angular/elements to take advantage of Angular elements. Under the hood, not only does this add the dependency via the package manager, it's also going to go ahead and configure and set up my project to take advantage of this dependency, to take advantage of this project. So let's actually go ahead and take a look at these three commands that we've talked about and see how developers can take advantage of this. So to illustrate the general concept of schematics, I want to walk through several examples where we use this directly within Angular. And so you can think of schematics as performing a transform to your existing Angular project. And we actually use this in a lot of different places. So if you use ng-new, what we're going to do is we're going to take in a blank empty project with nothing in its tree, and we're going to return a set of scaffolded out files that represent a new project. So you can see here, if we run ng-new NativeScript webinar, we're going to get out all of the default files for a new Angular project. And so I can just run this command. I'll have a project that I can ng-serve and ng-update. And you can kind of understand this a little bit under the hood if we look at a blank schematic that you can create with our command line. And so this is a blank schematic that's created with schematics, of course. And really what you can see is that we are defining a rule, and that rule then just takes a tree and it returns a new tree. And so there's a bunch of functions that you can use to modify the tree and parse the ASTs and actually understand semantically what's going on within an application. But at the heart, that's really the core concept, is you're taking in a tree and you're returning an updated tree. And we take advantage of this really powerful kind of core idea in a lot of different ways. So if I take a look at this project and I ng-add at Angular/PWA, what's going to happen is several steps. So I'm going to download and install this package from my package manager as it's configured in the Angular CLI. I'm going to add that into the dependencies of our project. And then what we're going to do is we're going to look for a specific set of files in that Angular PWA file and dependency. So if we check out the node modules Angular PWA folder, we can actually follow this entire chain of events in terms of what's happening. So you'll look in here and you'll see that it's got a schematics entry in the package.json file that points to a collection.json. A collection is really just a set of schematics that are available. And so if we look at the collection.json file, we can see that there is a specific schematic named ngadd. And this points directly at a folder and a specific schematic for this ngadd function. And so when I'm running the ngadd command, we're downloading the package, we're looking in the collection for what schematics are available, and if there is an ngadd schematic defined, we're actually going to go ahead and run that. And it's very easy to look under the hood at what this is doing. If you actually pull up the source code here, you can see there's the collection, there's the PWA folder, and then just like we saw in the blank schematic, you can see all of the specific code here. And so they've got some helper functions, add service worker. You can nest schematics, so you can invoke another schematic from another project. Then you have to do a little bit of AST parsing to understand kind of what's going on within the project. But the ultimate output that a user is going to end up seeing is that files get both created and updated as part of their project. And so if we take a look at, for example, another ngadd command, such as ngadd at angular/material, we're going to see that not only are we downloading this and installing it from the package managers, not only are we creating new files, we're also updating existing files. And this is kind of the magic and the superpowers that come with schematics. So that's a little bit about ngadd and how it makes it easier to kind of get started quickly. We're working very hard with the NativeScript team to enable developers to take any existing Angular project and add in NativeScript superpowers to really increase the reach of their application. But there's another place where these schematics come into play, which is with our ngupdate command. With ngupdate, things work exactly the same, where we're going to resolve the package from the package manager. We're going to go ahead and make sure that we're downloading the correct version, managing peer dependencies, managing package groups, all those sorts of great features. But then under the hood, all we're doing is we're looking in that collection file again for a schematic named ngupdate. And so we can run ngupdate at angular/core. And so this shouldn't actually do anything because our packages are all up to date. But if there was a new version of a package, we would install it, make sure all the peer dependencies are correct, and then also run the ngupdate schematic. And so the power here, when you think about projects like NativeScript, is that if NativeScript needs to make a change, for example, let's say this probably won't happen, but let's say they need to change the name of one of their tags. ngupdate could actually go ahead and do that for you across all of your NativeScript files. So the NativeScript schematic could parse your project, it could find all the places that you use that tag, update the references, and so that as you update to newer versions of NativeScript, you can be more confident that you're going to be staying up to date and that it'll be easy to do so. So if you are interested in getting started with schematics, adding it to your own project, we wrote a guide called Schematics and Introduction on the Angular blog that really walks through some of the things that are happening under the hood with schematics in terms of how you can do it asynchronously, you can pull data down from a web API, the way that you can extend other schematics, and it walks you through getting the schematic CLI and creating your first schematic. Another recommendation I would do is definitely look at some of the projects that are out there on GitHub, such as in the Angular Dev Kit repo, where we have schematics for creating PWAs with ngadd. We've got schematics for our CLI, where you can actually see some of the cool things there. So we're really excited about the potential for schematics to help developers move quickly and stay up to date. We're really excited to keep working with NativeScript on these sorts of capabilities. So in general, what we're trying to achieve via schematics and via these new commands is really to help developers to move faster. Our thinking is that if we can use a deeper knowledge of the dependencies that a developer is using and a deeper knowledge of the capabilities of libraries and tools out there, we can more powerfully integrate these sorts of tools into a developer workflow. This is a really great example of why we're excited about working on these sorts of things with teams like NativeScript. So if you look at, for example, an existing Angular application that's only serving the web, we really love this concept that you could then take that same code base, add NativeScript to it, and then have a more hybrid-based application where I can share things like business logic, application architecture, hierarchy, and then just add things like templates that take advantage of NativeScript to allow me to have a single application, a single Angular code base that's able to serve both the web as well as taking advantage of things like native or installed mobile experiences. Because we find that whenever developers can reuse code, they can have a single architecture, it makes things much more maintainable and much more extensible. And so as we continue to kind of build out these tools and focus on things like making hybrid projects easier to compile, easier to use for developers, we're excited to see all the great things that we're able to do with NativeScript. Angular in particular is really good at doing this sort of code sharing with tools like NativeScript. Because NativeScript is a fantastic way to use your knowledge of JavaScript, your knowledge of XML and HTML-like structures to build these native experiences on mobile devices, where you get this native look and feel using actual APIs from the platform, actual capabilities being exposed to you in a way that you can take advantage of them using your existing JavaScript and web development skill sets. And so when you combine the power of NativeScript with something like Angular, where we bring this idea of the orchestration of an application, where we help you architect, we help you move faster with a set of tools, a set of libraries that bring the web into a place where you can kind of continue developing in 2018 and beyond in the way that is extensible, maintainable, and has a cohesive set of integrated tools. This is a really powerful combination that we're really excited to continue sharing with developers.
Awesome. Thank you, Stephen. So next up is Sebastian, who's going to speak more on how you can get the most out of using Angular with NativeScript. Remember to get your questions in on Twitter using the Ask NativeScript hashtag. Sebastian, take it away.
Hello everyone, my name is Sebastian Vitalet and I'm a Senior Developer Advocate at Progress. So today I want to talk to you about a couple of things. The first one is our integration with the Angular CLI. So the whole idea is that you should be able to use Angular CLI from within NativeScript projects. So you should be able to call things like ng-generate component or ng-generate module. And what we did, we actually slightly changed the way components and modules are generated so that they're pretty much prepared for working with NativeScript projects. So the setup is as follows. You need to install Angular CLI on your machine, and we recommend you to use version 6.1.0 beta 0, which is the version that actually has the bits that we require to actually do our schematics. And then you also need to install NativeScript schematics. So this is where the scripts of how we generate components and modules the NativeScript way actually are located. And also NativeScript schematics will be later on used for code sharing. So this is also quite important. And then if you have an existing NativeScript project, what you need to do is add an Angular JSON to your project. And this will have configurations like the name of your project or the source root. And this is even pointing to the location where your app folder actually sits. So by default in a NativeScript project, this will be a dot. If your project is structured in a way so you have source, then app folder, then source root will be basically saying src. And you could create this file manually, or you could use a schematic for that. So if you install schematics, and then you could use NativeScript schematics, so you could call NativeScript schematics : Angular JSON, and then provide the name of your app project. This will actually generate Angular JSON for you. And then once you complete all these steps, you could go to your NativeScript project and then call things like ng-generate component home. And then this will generate your component, or ng-generate module navigation, etc. And then all Angular CLI generators will work out of the box. So thank you schematics for that, because this basically made the work with NativeScript projects a lot easier. We could also use schematics for scaffolding our projects. So we could use an ng-new command. And if we say ng-new and then provide a collection, so in this case again is our NativeScript schematics, and then you give it a name like my app, and this will go and generate you a NativeScript project. If you do something similar but you want a code sharing project, you just have to add --shared to your project, and then we're ready to go. So let me show you how this works in action. So what I have in here is one of our templates, which is the side drawer template for Angular, and I'm just gonna go and modify this project. So we're gonna start with running a schematic to generate the Angular JSON file, and that worked pretty quickly. And now our project is ready to run Angular CLI commands. So now I can generate a component called hello, and there we go. We have a bunch of files generated, and including like just a button saying hello works. And I can also generate some modules. So let's say generate module called zoo, and then that automatically generated module, and you can see includes automatically NativeScript common module and no error schema, which is required by NativeScript. And I could even generate some components inside zoo. So I can say ng generate zoo, and then I could say frog, because we should have frogs in the zoo. And then we could also add a fish. And then this not only generates a fish and frog component inside the zoo folder, but it also added it to the declarations of our ng module. And then we could also use it to add modules to, let's say, components to existing modules that we have over here in this project. So let's add a component to the home module, and we should have a lamp inside here, and maybe we should have a table. So if we go now to the home module, now we can see a lamp and a table, and we could even try to add it to our project. So we could say app lamp and then app table, and this should add it to the project, and then I can run tns run iOS, and shortly this should appear. And then the reason why I can use app lamp and app table is because actually the table selector has the app table, and the same thing actually happens for the lamp. So we have the app lamp over here, and let's check our project. And here's our app. So it still has like all the bits as you had before, but now we also have the lamp works and the table works. And that's pretty much like how this thing works. And now let's get into the code sharing and how to do it. So the whole idea is that we want to have a monorepo project that will have like all our pipes, services, and directives, and then we'll have our components, and which would share the TS class code, but then would have separate web and NativeScript HTML files. And then also we could share a lot of the modules and the components that they have, the navigation they have, but we'll probably have two separate ng module files, one for web, one for NativeScript. And then we'll need some sort of a build process that either takes shared web files to generate a web Angular app, or the shared files and the NativeScript files, and then generate a NativeScript app. So how do we do that? Well, again, we can come back to our schematic to generate a brand new shared project. And then this will give us a project in a format that we kind of expect, and which will allow us to do something like ng-serve, and then this will use Angular CLI to build a web app for us. Or we could call tns run iOS bundle or Android -- bundle. And then this will first run through Webpack. So Webpack will go and pick up all the shared files and the NativeScript specific ones, and then in memory recreate like a NativeScript project structure. And then as a next step, you will use NativeScript build to actually build the application for us, which is pretty cool. And also the way we do code sharing, basically if we have a component, let's say called name component, would then have two separate HTML files. So one will be name.component.html, the other one will be the same name with .tns, or you could probably even change this extension if you really want to. And if we want to, for example, add CSS, we could have again two separate files, but then the NativeScript one will have .tns, .sas, or CSS. So let me show you how this thing kind of looks in action. So first I'm going to start by generating a new project using ng-new. So ng-new collection, that will be NativeScript schematics. And the name of the project is going to be cinemas, because I want to display some cinemas, and the type of it is shared. And then I'll go just inside and run npm install very quickly and let it run in the background. So let's just have a look at what's inside our Cinemas project. So out of the box, this project is ready for code sharing. We have our Angular JSON, which points to our default collection, but it also has a build configuration for our web projects. We also have ns-config file, and this one, for example, provides us with ability to change the extension. So if you don't want to use .tns for NativeScript files, you can change over here, or you could even add one for the web extensions. We also have two separate TS configs so that you could add some additional properties which are specific for TypeScript for your web or NativeScript projects. And then inside source, we have basically our default scaffolding of the project. And the key thing here is we have this app module file. So there's one for web and one for NativeScript. So what I want to do next is generate a service called Cinema. And this is going to be the service that we use for the whole project, and I'm just gonna copy and paste from my code snippets. And then this service uses HTTP client, and then it has this function get cinemas. So if we give it a location, it will go to this URL and then pull the data from over there and then return an array of cinemas. And then since we're using HTTP client, we should probably add it to our app modules as well. So let me go to app module for the web project, and we have to import HTTP client module, and that comes from at angular/common/HTTP. So let's add this over here. We also should probably provide our service, so cinema service, it's added. Now we have to update our app module for NativeScript. So in this case, we are going to use the NativeScript HTTP client. So NativeScript HTTP client module, and that comes from NativeScript Angular/HTTP client. So let's add this to our imports, and then also add cinema service to our providers. And now our project can use the HTTP client that is specific for web and for mobile. Let's add now a component that we can display the cinemas. So let's ng generate component cinema list, let's call that. And this is actually gonna generate a new folder which has a component for the cinema, and then inside the constructor we can, for example, add our cinema service. Let's add it over here, and what we can do next is basically have like a way to capture our cinemas for a given location. So let's call it cinemas. We don't have to really give it a type, and then on ng and init we can say this.cinemas equals cinema service get cinemas, and I'm just gonna put London by default, and that should do part of the trick. Then inside our HTML, what we can do is just create a quick div, and then this one we'll just call ng4, and then we're just gonna get cinema from the cinema list. So cinemas, and I'm gonna use an async pipe, and that should do the trick. So I'm just gonna display the cinema.name. And we could do something very similar for NativeScript. So in this case, I'm gonna just create a quick list view, and we're getting the data from cinemas, and again using a sync pipe. We're not gonna use any of those, and what I will do is just call let cinema be an item, and then just say cinema.name, and then that should display the data that we need. Pretty much we are almost there to get this part working. So there's the cinema list component has been added to declaration for the for the web module, but it doesn't get added automatically just yet to the NativeScript one. This is something that's going to come in soon, but I can add it to the imports over here. And now the only thing that we have left to edit is actually just our navigation. So what we have to do is add a path to, let's say, cinemas, and then the component is gonna be cinema list component. And let's change the default one from players to cinemas. And at this point, we should be able to just call ngserve-o to build the web project. And then I could also at the same time run tns run ios --bundle to build a mobile project. And you can see the web project found a bunch of cinemas, so those are loaded live from our web service. And if I check our mobile application, we have the same list of cinemas displayed over here. So I understand this is a pretty basic example, but this is how more or less these things work, and this is the general idea of what we're trying to achieve. And the final bit I want to talk to you about is project migration with schematics. So this is about taking a scenario where you started with a web-only approach or mobile-only, and you want to go into a code sharing structure. So we have a bunch of schematics that actually help you do that. So if you have a web project, you can call ng-new my app, and then you can call ng-add NativeScript/schematics, and then this will take your web project and then convert it into a code sharing one. Then you could call ngserve or tns run ios or android -- bundle, and then either get a web or a mobile application. You could also look at a scenario where you have an existing NativeScript application, and then you could call something like ngg add web. This schematic is still in progress, is not yet complete, but it will be soon. But the idea remains the same. After you run it, you should be able to call either ngserve or tns run ios or android -- bundle, and you should get a web or a mobile application out of it. So this first step, it basically just converts the structure of your project, but it doesn't help you migrate your modules or components just yet. So for that, we have a separate set of schematics. So if you have an example, like a home component over here that is web only, you could run something like ngg migrate component, and then give it its name as a parameter, and then the schematic will take it and then convert it into a code sharing structure. Also, if you have a module that has multiple components, you could run something like ngg migrate module, give it a name, and then this would take and migrate each of your components first, and then you migrate the remaining bits of your module. So the whole idea is that to do the migration, we're looking at 3 commands. So you can call ng-add NativeScript/schematics, and that will take and then convert your existing web projects into NativeScript projects. The caveat is you should be on Angular 6 and then using Angular CLI 6.1. And then you could use ngg migrate component and migrate module to help you with the migration of those individual modules and components. So let me show you very quickly all of that in action. So what I have in here is a slightly more advanced version of our cinema project, but it's web only. So I'm just going to run ng-add NativeScript/schematics, which first is going to go and install NativeScript schematics into this project, and after that it will run its ng-add schematic that is built in over in there. And that actually does a bunch of things. One of the first things it actually does, it updates the package JSON, this one over here, and then it adds like the NativeScript specific packages. So it will be like NativeScript Angular. It also installs NativeScript Dev Webpack, but it reconfigures the webpack.config.js so that, for example, we know that the extensions that should be used are the TNS one. It also adds the nsconfig file to this project, and then apart from that, it updates the files inside the app folder. So in this case, it will add the app module, it add the app routing file, and then it will add additional app components. So this one, for example, start with a page router outlet for your navigation. And then from here, what we can do is just go and convert some of the components and the modules that we have here. So here we have a home component, and I can just call ngg migrate component -- name equals home, and then this will go and then add the .tns file, which we can go and update to put NativeScript specific bits. But then also you can see it updates NativeScript's app module, so automatically the home component gets added here. We also have a cinema module. So what I can do is try to migrate this one as well. So I can call ngGenerate migrate module, and the name is gonna be cinema. And then again, this will update each of our components inside, and then additionally it will add a cinema module file for us. So that's pretty cool. And then to make it work, our app module.tns will actually require a NativeScript HTTP client. So let's add it just over here. We should also import the cinema module itself, and we will need the cinema service. The next app, we have to just update the navigation. So if I go to the app routing for the web project, I can actually get our app routes from app.routes file. So I can pretty much do the same thing for our NativeScript equivalent. And let's get that actually imported. That's done. And then the remaining bits are just updating the templates. So I could, for example, just update NSHome to just says welcome to Filmix, a UK cinema finder. Then let's update our listing. So again, NS listing, and then this will just give us a list view that displays items from the listing object, which is available from over here. And then finally we have a cinema list, so we can also update the cinemas. So we'll get like a bunch of buttons that we can change the location, but also display all the cinemas. And then at this point we can basically run tns run ios -- bundle, and then run ng serve -o, and then wait for the projects to be built, and that shouldn't really take long. And by the way, like, this project also uses Angular's material design, so the actual list of the cinemas should look a little better. So I can just go inside, say let's look for cinemas, here's a list of cinemas, and then if I, for example, click on Curzon Soho, it takes us to another page. And if we look at a similar thing for NativeScript, we can say, hey, show me cinemas. I can change location and then maybe see what are the films in Odeon Bristol or Scott Cinemas. So we can do pretty much the same in both platforms. And that's pretty much it from me for today. I hope you enjoyed this part. And next up is TJ. So over to you, TJ. Bye.
Perfect. Thanks, Sebastian. I'm TJ from the NativeScript DevRel team, and today I'm going to talk to you about what is new in NativeScript 4.0 and also what's new in NativeScript 4.1 as well. Now, first of all, there are a lot of new features that we shipped as part of these releases, more than I have time to cover today. So what we're going to do is cover a few of the more important things that we shipped as part of these two releases. And at the end, I'll give you a few links to documentation pages you might want to use to read up and learn more. The single biggest updates we shipped are related to performance. NativeScript 4.1 included an update to V8. the JavaScript engine we use to render your applications on Android. Between the V8 update and also some updates we've made to our Webpack integration, NativeScript apps that use 4.1 start something like 50% faster on Android, so you get some massive performance improvements. To actually get these updates, you really only need to do two things. First, just update your Android runtime version in your package.json. Make sure you're using version 4.1, as that's the version that's going to bring in the new version of V8. Next, you'll need to upgrade your NativeScript Webpack plugin to version 0.12.0. Now, this one is a little more work, especially if you're already using the NativeScript Webpack plugin. So if you haven't already upgraded, head to the URL bit.ly/ns-webpack-update and follow the steps there, which will get you up and running with the new version. Now, to show off some of the other new features in action, let's head over and do a demo. Let's start in NativeScript Marketplace and on the new samples page. Here, you can find a number of fully functional samples for implementing all sorts of things in your NativeScript apps. For this demo, I want to show some of the new changes related to drawers and tab views, so I'm going to search for a drawer demo and bring this up and go ahead and launch it in NativeScript Playground. The cool thing about NativeScript Playground is I can take this sample, hit this QR code button, and then using the NativeScript Playground app on my device, scan this QR code, and really just instantly see what this sample looks like. I can also see changes that I make immediately apply as well. Now, if you remember, this is a sample for the NativeScript drawer, and the code you see here controls really the UI you see on this main screen. But the thing I want you to notice is not this code itself, but actually what you don't see. Before NativeScript 4.0, really each page you had to build had to contain the markup for handling either a drawer or a tab view, depending on what you're using for your apps. But with the new NativeScript architecture, you now have that ability to put that same code in a more global place. For example, in this app, this is being an Angular app, that code is in the app component TypeScript and app component HTML file. This change not only cleans up your code, after all, you get to consolidate all of this common view, drawer, or tab view stuff in one place, it really also improves the performance of your apps as well, as NativeScript doesn't need to recreate this user interface every time that you navigate. If I go back to the marketplace and switch over to the templates tab here, we've updated all of the NativeScript app templates, and there's quite a few here, to follow these new architectural patterns. So if you start from any of the official templates, you'll be able to take advantage of this improved architecture right away. The next change I want to show you is for the NativeScript CLI and NativeScript Sidekick, so let's switch over to a local environment. Here in my terminal, I've already created a NativeScript app using one of those templates, in this case the drawer template, and I just called it my drawer app for simplicity. Before we actually run this app though, I want to show off another new NativeScript 4 feature, and that's the ability to generate both splash screens and icons for your app. Now you might know that all NativeScript templates ship with a default set of application icons and splash screens. But of course, you'll need to switch out these icons with your own app icons and splash screens before you push your apps out to the stores. And if you've went through that process before, you might have an idea of how tedious and error-prone it can be to assemble this ridiculous set of icons that match these file naming conventions. You can see Android and iOS have all sorts of different names, dimensions, all sorts of things that you have to know and put together. From the NativeScript CLI, all you need to do is run TNS resources generate, icons, and then pass in a path to the image you would like to use. The image you should use should be 1024 by 1024 pixels, so NativeScript has the quality it needs to generate high quality icons for really all platforms and resolutions. Next, for splash screens, again use the TNS resources generate command. This time pass in splashes, provide a path to the image you'd like to use, and also provide a background color property, which NativeScript will use to fill in the color that appears sort of around the icon in the splash image files. If you're a NativeScript Sidekick user, your life is even easier, as all you need to do is visit the Assets tab as part of your app within Sidekick, and then take the icon you'd like to use and drag and drop it into both this icon slot and the splash screen slot as well, and Sidekick will take care of really everything that needs to happen to generate the icons for your app. When you're done, if you head back to the app resources folder for your app, you'll see that the new icon that you selected has been slotted into all the appropriate names, all the appropriate folders for both Android and iOS for your app. It's really just that easy. To see these new app assets, we'll need to actually run this app. Now, I could do that by just executing TNS run and sending this app out to this iOS simulator, this Android virtual device that I already have hanging out over here. But since one of the other new NativeScript 4.0 features is the ability to run your apps on multiple iOS simulators, I think we really need to up our game here. So with a little time-lapse action, let's see how big we can go. All right, so TNS devices says that we're up to 13 devices. I think that's going to have to do. I'm kind of out of screen real estate here. So let's fire off TNS run and just mass deploy these apps so you can see these icons and splash screens across all these various devices. There's something very satisfying about watching that. And now that we have all these apps running, I do want to show you another one of the new features we shipped in NativeScript 4. And that's the ability to apply gradient backgrounds to UI components. Now, what this means is I can go into the CSS or SCSS file for one of my apps and just apply a background that is a linear gradient. And I could use the exact same syntax that I would use as if this were a web app. Which is pretty cool because, again, remember, what you're seeing here is not a bunch of web apps. You're seeing a bunch of completely native iOS and Android apps. So this is some pretty powerful functionality. So we could add some basic CSS like that, but since we have 13 devices up here, I thought we'd have a little bit more fun than that. So what I did is I wrote a little bit of code in the TypeScript that backs this page to just generate two random colors and to create a gradient that blends the page's background from one color to another. And what I'll do is I'll save that and we'll see some, hopefully if this works, some random color gradients start to pop up on these devices. So you can see how seamless and easy it is to add these gradients to your app. And also if I just save a change to this app to push it out again, I'll also note just how fast NativeScript is actually able to live sync these changes. So I'm not messing with this video at all. NativeScript is actually able to push out all of these changes in real time. And while we're having fun and while these final devices push out here, there is one very last change that I want to show you, and that is related to NativeScript's support for augmented reality. One thing we shipped in NativeScript 4.1 is support for the vector type on iOS. Now, for most apps, you probably won't be using vectors, but you might if you're working with augmented reality, as Apple's ARKit makes heavy use of this type. Now, what you're seeing on the screen here is my iPhone, and you can see a little demo app we have that lets me control a 3D model, in this case, this drone on the fly. And the 3D positioning you see here, really just where this drone is relative to the camera, as I play around with this here, is made possible by our new vector type support. So if you are working with AR in NativeScript, make sure to subscribe to the NativeScript blog as we have some detailed write-ups on the changes coming soon. And that wraps up my demo of the new NativeScript 4 and 4.1 features. If you want to learn more about these releases, including the stuff that I didn't have a chance to get to, make sure to check out these two URLs, which walk you through all of the features in these releases in a lot more detail. Now, to keep the fun going, I'm going to pass the baton over to my colleague Jen, who's going to talk about what's new with Vue. Jen, you want to take it from here?
Thanks, TJ. Hi, everyone. My name's Jen Looper. I'm a senior developer advocate here at Progress. You can always find me on Twitter at Jen Looper. And I'm here to talk to you today about code sharing with Vue.js. Now, we know that sharing code between your web and mobile apps is kind of the holy grail. We have a great story with the Angular community, and we're working towards having just as great a story with Vue.js, with NativeScript, sharing code between your NativeScript app and a web app. So let's get started. I'd like to share with you the story of how we've thought about sharing code between web and mobile within the NativeScript Vue community. Now, this story opens by introducing two brave knights, Tiago Alves and Igor Randzielovich, very familiar names within the NativeScript Vue community. These are folks who have worked very hard to create some dialogue around how we ought to share code between web and mobile. This story also involves me as your requisite damsel in distress. I'm always running around giving talks on code sharing, and boy, do we need a solid code sharing story for the Vue community. So like I said, our community has sallied forth to create a good way to share code. There are a couple ways that we're going to go over today, and let's just see how they look. So the first attempt was actually by Igor, and he went ahead and bravely did a PR on the Vue.js repo itself, saying, why don't we take our normal implementation of an SFC and extend it so that we could have blocks within the template and make this part of Vue itself. So we would have template native, template web, and then the Vue loader would pull out those pieces that need to be built and create apps with those for either the web or for mobile. Same goes for style native, style web. And we had some back and forth with the core team, and this issue was eventually closed. Evan is not particularly interested in tinkering around too much with the way SFCs are created. SFC, of course, being single file components. So there's a particular syntax that they're wanting for Vue files, and there's not a great deal of interest in the community to change the way that these files are handled. Totally understandable. Well, so that was an idea that Igor put forth, and the issue was closed by Evan saying, you go ahead, you make a fork, see what happens, see how far you can push this idea. So that's exactly what Igor did. And he went ahead and forked the Vue loader, made a NativeScript Vue loader, and made it work for exactly what we need, pulling out bits and pieces of these single file components and making Webpack work to build them into a web app and a mobile app. Now the structure of the code, like we just saw, looked a little bit like this. Within one SFC, you have blocks. So you have the template web with a certain amount of web markup. You see divs and ULs and lists and all kinds of extra markup that you might find, for example, if you use Vuetify, which is my favorite way to style a web app using material design. And then in your native block, in the same file, you would have NativeScript markup. You would have a stack layout, you'd have a list view looping through your seals array and creating a stack layout with a label inside. And that would give you a nice list. So the NativeScript Vue loader would then pick out the pieces that it needs to compile. It works pretty well. You can take a look at this and try it on your own. I made a little app to display seals, as you saw, and this is how, very simple, this is how it looks on the web. And then the mobile app looks like this, types of seals. I like seals. Well, the next chapter in this story was proposed by our other knight, Tiago Alves, who is kind of a wizard of Webpack. And he said, you know, maybe we shouldn't rely so much on this fork of the Vue loader. Why don't we just make Webpack do the heavy lifting for us? So he committed a sample, which is this NativeScript Vue code share demo. And it's quite an interesting project. I advise you to take a look if you're interested in seeing how this all might work. But the code structure looks a bit like this. So your single file components, your SFCs, go into the components folder, and they have a certain naming convention. And this is actually the structure that I think Evan would prefer, that you would name your native script something like home Vue or home native Vue, and then your web app would be home web Vue. So you have this naming convention similar to what we do in the Angular community. And then you would share code and include this shared code in your SFCs with a mix-in structure, and I'll show you in a minute how this works. But you have a shared service. I borrowed the name. I'm kind of used to using services in Angular, so I just created a service view here, and that is shared. Those are your methods that you can use to query an API. And then you have these entry points, main native.js and main web.js. Those are the two entry points you need because you need to start up your mobile app in different ways than you start up your web app. And we'll go over how that looks in just a second. And then you can have some global styles that are, native to your NativeScript app. You can use CSS files because you can use Sass in this project. And then you can use global web styles to style your Vuetify web app. So this is all sort of organized not via blocks in the SFC, but actually via separate files with a certain naming convention. So that's kind of an interesting way to do this sort of thing. Let's take a look at the code actually. So your SFC structure, again, we have two different files here. We have home view, which is the NativeScript app, and you instantly know that it's a NativeScript app because we have an action bar with a lot of emojis in it. We have a scroll view and then a wrap layout that's going to create a little wrap layout of dogs in a list and an image embedded in that wrap layout. And on the web, we have a template again, and we have a container. Here I'm using Vuetify, so I have a V container with a V layout, V flex, and a V card. And inside the V card media is the image of the dog. So always the markup is a little bit different on the web than with your NativeScript app. So the entry points for the web are also slightly different. Here we have main web.js, and you're going to import Vue from Vue as you normally would. And then we're going to use the Vue router. And you import your components, your home components, in Vuetify for the web because that's how we're going to style it. And you can also import your global styles. And then you use Vuetify, give it a theme, and then you're going to start up your Vue app. You're going to scaffold it by injecting your code into this app ID and then rendering it with your starting page being the home SFC. So this is kind of extremely standard way of starting up a regular web app using Vuetify. Your entry point for mobile looks different, looks a little bit streamlined. We're not using Vuetify because we can't do that in a NativeScript app. Totally fine, you have other options for styling. But here we import Vue from NativeScript to Vue. So again, a little bit different way of scaffolding it. We're using NativeScript to Vue. But then we also go ahead, like what we do on the web, we import home and we import our styles. And then I have this Vue config silent set to false because you can get more verbose logs. And then you just start up your app by just rendering it and invoking start. So there's no injecting of code into a div because there are no divs in a structure that has no DOM like a NativeScript app. So it's kind of nice to have these separate entry points, and then you kind of send the app along on its way to render home. Now, this is where this gets a little bit interesting because the script block in the single file component in this structure is actually identical. So we just import the service, and then we use that service within a mixin so that anything that is gathered up in the service is sent down to the child component. And then on the created method, we just load the dogs, which is coming from the service. That's a method in the service, load dogs, which is querying the dog API. It's the dog CEO API, one of my favorite APIs to use. And then in the shared service, here's where we get into the actual code sharing. So we've forked all of the SFCs. We've changed naming conventions so that the Webpack will pick up the right file to render for the right platform. But in our service, we have just one service, and it's shared between web and mobile. So all we're doing is using Axios, which is a library very commonly used to make API calls in Vue. We just query Axios in this load dogs method. We're asking Axios to query this API and give us 50 random dogs from the dog CEO API. Save that into this dogs list array, and then via the mixin, we're going to pass that into our NativeScript and our web components. And this package also includes support for scoped styles that might be page specific. Here's an example that I used for my NativeScript app. And then it also has support for Sass, where you can have global styles for web or for mobile as you so choose. And here's the result. We have a nice Vuetify styled web app, and also an Android app, and also an iOS app, all from shared code. All right, let's go back to our story. So what can you expect going forward with this project? Well, we are making a lot of progress, as you've seen. In particular, we're getting ready for Vue 3 and the next release of the Vue CLI. Now, Vue 3 is really exciting for third-party folks like us because it's going to allow us to develop a custom renderer, and that's going to actually render a certain amount of our own NativeScript Vue code obsolete. So this is something to watch for, and we're very much looking forward to this. It'll make our project easier to maintain. Also, the next iteration of the Vue CLI is going to allow easy creation of extensions via plugins so that we can extend the CLI and create something like a command such as Vue add NativeScript Vue or even Vue add mobile, similar to what the Angular community has created. And this is really helpful if you need to bolt on a mobile app to your existing Vue web app. I hear this a lot of people who need this sort of functionality. I've got a great web app and I need a mobile app just bolted on. Well, go ahead and add it via the CLI by means of a plugin. And the creation of that plugin is actually in process. Most of the parts are done. Igor is handling this, and just the Webpack part needs to be completed. So I'd just like to thank all of our great community members who have made this implementation possible. Igor and Tiago and Pascal and Duane and all the other great people on our NativeScript Slack channel in particular who are so helpful in creating awesome tools that allow not only NativeScript Vue to spin up mobile apps, but allow code sharing between web and mobile. So with that, I will go ahead and pass this over to Rob. Thanks so much.
Fantastic. Thank you so much, Jen. Thanks as well to all of our speakers today, especially to Stephen. Now, before we sign off, I did want to remind you to get your questions in on Twitter. If you have any questions at all, use that AskNativeScript hashtag. So as promised, I do want to spend a minute with you going over the next release. As NativeScript continues to mature, we remain focused on our core values of providing an unparalleled developer experience along with the most performant framework in town. And as many of you know, we work on a roughly 6-week release cycle. This means 4.2 is coming already in about mid to late July. So what can you expect from the 4.2 release? Well, we are actively working on a lot of improvements that will show up in 4.2 or shortly thereafter. First up is performance metrics. Now, you already know we have a laser focus on performance, so it's time we proved it to you. We'll be coming up with verifiable and repeatable metrics for NativeScript versus other frameworks like React Native and traditional native iOS and Android apps. We're also working on making it easier for you to debug your apps that are using Webpack. And we'll be providing improvements for our code sharing strategies, some of which you heard of today. And we're looking at improving live sync performance, fixing some bugs, but also making it considerably faster. Finally, we're starting to look at providing what you could almost call live sync v2, and that is a true hot reload of your NativeScript modules to provide an even better iterative development experience. So look for more news on these fronts in the coming weeks. Now, when we're done here, I encourage you to check out all the resources we've been talking about today. NativeScript Sidekick is your best friend when it comes to bootstrapping your app with a template, managing plugins, creating app icons, and managing cloud builds. The marketplace is where you're going to find plugins, more app templates, and the sample code we discussed earlier. Finally, the playground is a great place to get started with NativeScript since everything runs in a web browser and requires no local installation. You can also think of it as JS Fiddle for mobile apps. All right, thank you all. Now, investing in NativeScript and Progress for your mobility needs has never been an easier decision. Thank you again for attending and have a great rest of your day.